today's lecture, I will explain the basics of what we call as a character LCD. Now, as a part of today's lecture, I will first discuss the few points of what a character LCD looks like, then what is the pinout diagram of a character LCD, and we'll understand how to use a character LCD, and then practically using it as part of a display. So that said, let's start today's lecture. Now, LCD stands for liquid crystal display. So this is what your typical LCD would look like. Now, as you know that an LCD is used to display information. It also makes your project more interactive. As you will see, it is quite easy to interface. It is easy to buy in the market. It's available everywhere. And the documentation and tutorials are available to a great extent. So let's look at the pin structure of a typical LCD. If you hold your LCD towards you such that the pins are on the top facing you, then pin number 1 is the leftmost right through pin number 16. We can divide the pins of an LCD into 3 sections. It's just for a clearer understanding. We can divide them into power, control, data, and backlight. Pin number 1, 2 and 3 typically have to do with power. Pin number 1 you connect to ground or 0 volts. Pin number 2 is to power supply, which is VDD. You have 2 types of LCDs. One is 5 volts or 3.3 volts. Typically in the market you would find the 5 volt version. Then the third pin is a little more interesting. It's the contrast pin. Contrast would mean that in the foreground you would have a black screen or your black text like this, and in the background it would be typically green or blue. Contrast would mean the difference between the foreground, that is the black text, and the background, which is either the green or the blue. And if I want that the difference between the foreground and the background, that is, if you want the screen to be more black or the text to be more black, then I would increase my contrast, and that I would do using pin number 3. I will explain in the next slide as to how we would end up controlling this contrast voltage. Pin number 4, 5 and 6 are control pins, which I will explain during this lecture. Pin number 7 through 14 are your data pins. In the next slide I will explain that you can use your LCD either in a 4-bit mode, which is just using 4 bits of data, or in an 8-bit mode. And then pin number 15 and 16, the positive you need to connect to a power supply, negative again to ground, and that would actually light up my LED, which is at the back. It's a typical LED, so hence it needs a positive and a negative supply with a resistor on either one of the sides. Again, I still have to discuss these control pins, which I will shortly in this lecture. So let's understand this. As I said, pin number 1 would be ground. So as you see, we've connected it to ground. Pin number 2 has been connected to power supply. Pin number 3 is actually the central terminal of what we have a potentiometer. A potentiometer is a variable resistor where you connect the two extreme terminals to plus and minus, and the center terminal to the point where you would want a variable resistance. So as you see, I have connected the center terminal of my potentiometer to pin number 3, which was my contrast pin. Now pin number 4, as I said, it was register select, RS. Typically in my LCD, I have two registers. I have a control register and I have a data register. When I need to give control instructions such as clear the LCD, shift the cursor, then I would send instructions to the control register by making my RS pin 0. If I need to send data to the data register, so that for example I would like to display the character A, then my RS or my register select pin would be 1, or the input given to my LCD would be 1. Pin number 5 is my RW pin or my read-write pin. Typically, or most cases, we do not read from the LCD, as we just want to display on the LCD, hence we would just write to it. So for that, I have to make sure that my RW pin is always maintained at 0. So hence we have connected the RW pin to ground. That said, pin number 6, as you see, was my enable pin. Pin number 6 is that whenever I need to read data or write data onto my LCD, I have to make sure that my LCD sees a positive edge. Please understand, a positive edge signal on my enable pin. So always at the positive edge of my enable, it acts like a clock to my LCD. So when I give a positive edge at pin number 6, at that time my LCD understands that I have to do a read or a write or basically even a control instruction. As I said, that to control the backlight, I would connect pin number 15 to a positive voltage and pin number 16 to a negative voltage, that is ground. But we always make sure that there is a resistor in place, because we do not want to damage the LED. As I have explained before as well, that whenever there is an LED, we always connect either the anode or the cathode via a resistor. The anode goes to a positive power supply, the cathode goes to a negative ground, and there's always a resistor either here or here. Okay? So just to recap this section, my 3 power pins, my 3 control pins, 8 data pins and 2 backlight. We understood data register, control register. Before we move on to the next section, I'd like to touch upon another concept, which is using the character LCD in a 4-bit mode or an 8-bit mode. Now when we use the character LCD in an 8-bit mode, we can write into the LCD 8 bits at a time, but obviously that uses more number of wires and connections. On the other hand, if we use 4 bits, we are going to save on the wires. However, to use it in a 4-bit mode, there is a small thing that we need to know, is that given 8-bit data, if this is 8 bits, given that we have to divide it into 2 halves, the upper 4 bits and the lower 4 bits, it's also called as a nibble, the upper nibble and a lower nibble. So when I have to send 8 bits of data, which is your character, which is information, or even if it's control information, which we will see in the next few slides, then I first send my upper 4 bits, which is the upper nibble, and then after that I will send my lower nibble, which is the lower 4 bits. So on the other hand, if I'm using it directly in 8 bits, then I don't have any of those complications. I directly just load both together, that is 8 bits at a time, but again, as I said, that uses more number of wires. This is an important thing to know, that when we build larger systems, you have a microcontroller and you would try and use as fewer wires as possible, and as it is, we are displaying information which does not need a very high speed. Since we are displaying, as it is, things that move very fast, we will not be able to see them. So most of the times we are very comfortable using the LCD in just a 4-bit mode. I would like to spend 2 minutes quickly recapping data and control information. To send either of the two, as I said, that there is a data register and then there is a control register. How does my LCD know that which register am I sending information to? That is because of my RS pin. If my RS is 0, I would be sending control information. If my RS is 1, then I would be sending data. But either of these two, we have to make sure that my RW or my read write is 0, which shows that I am writing to my LCD, and also I can only write to my LCD at the positive edge of my enable pin. So it's a combination of these three that I can actually decide whether I am sending data or I'm sending control information to the LCD. I hope this is clear. So now let's understand how do I work with an LCD. That is, I'm writing to the LCD to display data. As I said, my RW needs to be 0, my RS has to be 1, so that if I'm selecting the data register, my LCD will latch the data or will take the data on the positive edge of my enable pin. However, I as the user need to present the data. I need to present the data on the pins, the data pins, to the LCD on the negative edge of my enable signal, so that I present the data here, and on the next edge of the enable signal, my LCD can take the data. So the write operation is performed on the positive edge, but when I send the data, I have to make sure that I present it on the previous negative edge. Please understand, the previous. So I would send data here inside, but I would bring data on the outside first at the previous negative edge. So in the previous slide, we understood the method of displaying data, that is if I like to send data, but this particular slide discusses how do I send control information. There are multiple instructions that I need to work with. I'll explain all of them briefly. This is the instruction that I would send. It's a 8-bit hexadecimal. When I say 0x30, this would mean an 8-bit data, which is 0011, which is the decimal 3, hexadecimal 3, and 0000. So just to be clear about 8-bit hexadecimal, how that works. Similarly, 38 would be 0011 and 8 would be 1000. Okay. So that is the data or the control information that I would give to my LCD. So suppose if I gave the command or the 8-bit data 30 hex, I would be telling my LCD that I would like to set my LCD in 8-bit mode, one line, so I'm just using one line of the LCD, and the font size would be 5:7. If you look at your LCD very carefully, it is built up of a very dotted grainy structure, which is 5 dots this way and 7 dots this way. So each of these together form one letter. So if I want to do A, I would use a few LEDs like this, few of these dots to display the letter A. That I would specify here. Again, if I give the instruction 38, it would be 8 bits, but I would be using 2 lines, same font size. If I send the instruction 20, 20 would in hex would be 0010, 0000. Then I would say 4 bits, 1 line I would be using same font size. Again, you can understand this. If I send 06, entry mode would mean that I'm ready to send data and the cursor is at the first position of my LCD. If I send 08, then my display is off and my cursor is also off. If I send 0E, then my display is on and I also have a cursor, so you can see something, a blinking position to show where you are displaying on your character LCD. Display on, cursor off would mean my display is on but I don't have that blinking cursor. If I want to control the blinking, whether it should blink or not, then I have this instruction. If I want to shift the entire display left, the entire display, both the lines, then I would use this command. If I want to shift the entire display right, then I would use this command. If I would like to move the cursor just by one character, one position, then it would be this command. If I want to move it right, then I would use 0x14. If I'd like to clear the display and also the register, that is the DDRAM, which is a memory, then I would use this command. All of these lectures, cut from the arm. So all of these instructions, again, can be looked at in the data sheet. So typically with your LCD, you do have a data sheet, but I would just like you all to know that there are control instructions which you do need to take care of when you're working with LCD using any microcontroller or PSOC or FPGA or any other Arduino. I hope this lecture on the LCD display was clear. In the next lecture, we'll see how to use this LCD display with the platform that we are looking at.